Hello and welcome to Physics with Amol sir. So this video is for class 10 and we are going to continue with the chapter light, and this is part 4 in the series. I hope you have seen the other 3 parts before you have come to this. Okay. So far we have discussed the concept of reflection. We have talked about reflection by concave mirrors and convex mirrors. Today we are going to talk about the Cartesian sign system, mirror formula, magnification, and we are going to do some numericals based on the chapter of light. Okay. So once again I would like to repeat, make sure that you have seen the other 3 videos so that you get an idea of what we are discussing today. Okay. So let us talk about the uses of concave mirrors and convex mirrors. Now concave mirrors, if you remember, they are converging mirrors. Okay. They form real images. Most of the cases for concave mirrors are real images which are in front of the mirror and they are diminished. Correct? But in one case, the concave mirror forms a enlarged image. I hope you remember that case. Which is the case? That is when object is placed between the pole and focus of the mirror. It forms a real image, or it forms a virtual image and enlarged image. Okay. So that is where we use the concave mirrors mostly. Concave mirrors are used by dentists to check the back side of the teeth. Okay, if you have seen a small mirror they have, that is a concave mirror. It is also used as a mirror for shaving. Okay, so you can see a enlarged image. Then, if you remember, if you place an object at the focus of the concave mirror, we get image at infinity. This property is used in the headlights of our vehicles. So our headlight, the headlights of the vehicles, they have a concave mirror fixed behind the bulb. So if this is the bulb, there is a concave mirror fixed behind. So we can get a beam, an intense beam of light. Okay, it is also used in torches, the same property. Now what are applications of convex mirrors? Convex mirrors, if you remember, they always form virtual images which are erect. Okay, so that property is used in our rear view mirrors. Okay, in our vehicle we have a rear view mirror which helps us to see the vehicles behind. So that rear view mirror is nothing but a convex mirror. Okay, why we use a convex mirror? First reason, it forms a erect image. Okay, we want to see erect images, otherwise it will be very difficult to understand. Other thing, the area can be covered in a much larger way with a convex mirror. So convex mirror can cover a large amount of area. That is why we are using convex mirrors as rear view mirrors. Okay. Next we talk about the Cartesian sign convention. Now what is the Cartesian sign convention? This is the sign convention we are going to use whenever we are going to make ray diagrams or we are going to solve numericals based on optics. Okay. So here is the sign convention. This sign convention is going to help us to understand the image distance, object distance, image height, object height. Okay, we'll see how. So this is the diagram. So the first rule in Cartesian sign convention is the object is always placed to the left of the mirror. Whether it is concave mirror or convex mirror, object should always be placed to the left side of the mirror. Okay, so that is the first rule. Object is always placed to the left. Next, the pole of the mirror will be considered as our origin. Once again, pole will be considered as the origin, and all the distances on the principal axis, they will be measured from the pole. And how do we measure them? If a distance is towards the left hand side of the pole, that distance will be called as negative. Okay, so distance towards the left of the pole will be called negative, and distance to the right of the pole will be called positive. Okay. Next rule, distances which are above and below the principal axis. So the vertical distances above the principal axis will be called positive and below the principal axis will be called as negative. This is the Cartesian sign convention. So here is the sign convention once again. So this is the mirror. If we make it like this, it is a concave mirror. If we make it in this manner, it will become a convex mirror. For now, we just want to understand the concept. So as I said, the pole will be the origin. Distances towards the left of the pole are considered as negative. Distances right of the pole are considered positive. Then distances above the principal axis are considered positive. Distances below principal axis are considered negative. And as stated before, object should always be placed towards the left of the mirror, whether it is concave, whether it is convex. Okay, so this is Cartesian sign convention. Now a few things to remember in this. Because object is always placed to the left hand side of the mirror, the object distance, now what is object distance? It is distance of the object from where it is placed to the pole. Okay, because as we said, distances are always measured from the pole. So the object distance for concave mirror or convex mirror will always be negative. The object distance is given by the symbol U. Okay, U denotes object distance. And whether it is a concave mirror or convex mirror, object distance is always negative. Remember, U will always be negative. Why? Because it is towards the left hand side always. According to the Cartesian sign convention, object is always placed to the left, thereby object distance is always negative. How do you measure object distance? From wherever the object is placed. Suppose here we have placed the object. So from the object to the pole, this is how we measure the object distance. Then V denotes the image distance. Okay. Now image distance can be positive or can be negative. How do we remember? If it is a real image, V will be negative. Okay. Why it will be negative? If you remember, real images are formed towards the left hand side. As they are formed to the left, real image, therefore V will be negative. But if the image is a virtual image, okay, virtual image means it has formed behind the mirror towards the right hand side, thereby virtual image, the image distance will be positive. Fine. So this is about U and V. Now what about the focal length, that is F? I am sure you remember focal length is distance between the pole and the focus. Now if it is a concave mirror, the focus will be towards the left hand side of the pole. Correct? So for a concave mirror, the focal length is always negative. Okay? This is for concave. Remember, so for a concave mirror, F is always negative. What about convex? In a convex mirror, the focus is towards the right hand side. Therefore, F is positive for a convex mirror. Okay, so these are important things to remember, because when we are doing the numericals, these are the concepts that will be required. So once again, object distance always negative, image distance, real image negative, virtual image positive, focal length for concave mirror negative, focal length for convex mirror positive. Okay, remember all these things. Remember the Cartesian sign convention. This will help us in solving the numericals. Now we move to another important concept, that is called as the mirror formula. This mirror formula will be applicable for concave mirrors as well as convex mirrors. What is the formula? Mirror formula is 1 by F is equal to 1 by V plus 1 by U. Okay, so what is the mirror formula? 1 by F equal to 1 by V plus 1 by U. And of course you know, F stands for focal length, V stands for image distance, and U stands for object distance. Okay, this is a mirror formula, you have to memorize this. And as I said, applicable for concave as well as convex. After mirror formula, we learn a formula for the magnification. Magnification gives an idea about the size of the image in relation with the size of the object. So whether you are getting an enlarged image or a diminished image, that will be given to us by the magnification. Magnification is denoted by small m. Okay, and the formula is m is equal to h dash by h. What is h dash? H dash is the image height. And what is h? H is the object height. Okay. So this is the formula for magnification. M is equal to h dash by h. There is another alternate formula for magnification. We can also write m as minus v upon u. Where again v is the image distance, u is the object distance. This is the formula for magnification. Remember these three formulae very clearly. Okay. So mirror formula 1 by f is 1 by v plus 1 by u. M is h dash by h, or m is equal to minus v by u. We are going to use this formula in our numericals. M, as you can see, it is a ratio of the same kind of quantity, h dash by h. Therefore, m has no unit. M will be a pure number. Magnification will not have any unit. Focal length will have a unit. SI unit of focal length will be in meters. SI unit of v and u will also be in meters. SI unit of h dash and h will also be in meters. So all the length that you measure, it will be measured in meters. Magnification, as it is a ratio of similar quantities, it will not have any unit. Next, we are going to solve a very simple numerical based on this formula. So let us see a numerical now. So this numerical will be for a concave mirror. So there is a concave mirror and an object is placed at a distance of 4 meters in front of the concave mirror. An image is formed on a screen placed at a distance 2 meters in front of the mirror. Find focal length of the mirror. Fine? This is the problem. So the question is, we want to find out focal length of the mirror. So I hope you have noted down the question. Okay? Because now I am going to remove the question from the screen and we will start solving. So as I always tell you, whenever we are solving the numerical, the first thing we will write is, yes, we are going to write down given values. What is the value given to us? We have been told where the object is placed. So object is placed, that means that is object distance. So we will write it as u. Okay. We have been told u is equal to 4 meters. But remember what I told you about object distance. Object distance is always negative. Therefore, we write u is equal to minus 4 meter. Understanding? So what is u? U will write as minus 4 and not plus 4 because it is a object distance. Next, we are going to write down image distance. That is what we are told. So we are told that the image is formed on a screen. Image formed on a screen means what kind of image? Real image or virtual? It is a real image. And because it is a real image, therefore the image distance is going to be negative. So we have been told is 2 meters, correct? So because it is a real image, therefore we write v as minus 2 meters. Once again, the object distance and image distance both are negative in this case. That we have understood from the question. So whenever you are solving questions on mirrors, okay, you have to underwrite the proper sign, otherwise the answer will be incorrect. Now, what do we have to find? So we have to find the focal length f. Okay, so let us begin. Solution. We will be using the mirror formula, of course. So what is the mirror formula? Mirror formula is 1 by f equals 1 by v plus 1 by u. So now let us substitute. How much is v? V is minus 2. So it becomes 1 by minus 2. Plus. Then we substitute for u. U is minus 4. So it becomes in bracket minus 4. So plus minus becomes minus. So we will get minus 1 by 2 minus 1 by 4. I am sure you can solve this. Okay. If you solve it, you will get the answer. We will take the LCM as 4. Okay. So it will be 2 2s are, so minus 2 minus 1. Minus 2 minus 1 is minus 3 by 4. So focal length 1 by f is equal to minus 3 by 4. But remember this is 1 by f. Therefore focal length f will be equal to 4 by 3 meters. Getting the idea? So this is the focal length of our given given concave mirror. Now I will give you one question as a homework. Okay, so you are going to solve this as an assignment. So note down the question. An object is placed at a distance of 20 centimeter in front of a concave mirror. An image is formed on a screen placed 5 centimeter in front of the mirror. Find the focal length and magnification of the image. Okay, so find focal length of the mirror and find out magnification of the image. So make sure that you have solved this question. If you get the answer, write it in the comments. Thank you.